Do you know the principle and programming method of polar coordinates in CNC turning and milling composite? If you do CNC turning and milling composite, be sure to watch this video. This video explains in detail the principle and programming method for polar coordinates, G12.1. It'll give you a whole new perspective on polar coordinates. Next, we will learn more about the principles of polar coordinate machining through programming. The CNC turning and milling system uses polar coordinates in a plane perpendicular to the z-axis of the lathe. Consists of a virtual axis C and a real axis X, which are perpendicular to each other. Simply put, mill-turn machining is actually based on three-axis machining centers through the overall rotation of the machining coordinate system into the mill-turn polar coordinates. The y-axis of the end-face coordinate system is transformed into the virtual c-axis, creating a polar coordinate system for machining end-face of CNC turning and milling. It is worth noting that the coordinate origin of the polar coordinates is coincident with the program origin during programming, and no additional offset is required. Polar coordinate machining always keeps the tool in the positive direction of the x-axis and the 0 point of the y-axis. Conversion of contour control from programmed commands in the right-angle coordinate system to linear and rotary motion by means of interpolation, where the virtual linear axis perpendicular to the x-axis is defined as the c-axis. It is worth noting that the current c-axis no longer represents the rotational angle of the workpiece, but the linear axis c-axis, which represents the length of the workpiece. First, the origin of the coordinates is at the center of the rectangle. The length and width of the rectangle are 80, 60 mm respectively, assuming that the tool performs a feed from the upper right corner. Then in program coordinates x80, c30. On the choice of x coordinates, diameter or radius programming, depending on whether the system is currently in polar coordinates or not. In polar coordinates, math. Diameter or radius programming refers to the x-axis. Make sure to check your system settings. If the radius is programmed, the program can be modified to x40, c30, the value of the virtual axis. C-axis does not need to be modified in the state of diameter programming 60. Since in polar coordinates, the virtual axis C can only be expressed as a radius, it is still c30. It's worth noting that in polar coordinates, the unit of c-axis is m, not the number of degrees. Therefore, based on the above, if the system is in polar coordinates for diameter programming, the program can be written as x80, c30. If it's radius programming, should be amended to read x40, c30. Make sure the system settings match the modes and units in the programming. For ease of understanding in this video, we have chosen not to consider tool radius values for avoidance. However, in actual programming, to ensure that the correct dimensions are achieved, it is still necessary to move the tool radius in the x and c axis by a distance. To ensure the quality and accuracy of the final machining results, the tool moves in the negative direction of the y-axis. The procedure should read c30. Move left. Move up. Move right. This is the content of the program on end-phase polar coordinates programming. Polar startup code should be added before the program. G12.1. After the end, cancellation code G30.1 should be added. It's worth noting that the positive and negative directions of the virtual axis C-axis may be opposite to G02 and G03 for different systems. If this problem is found, switch the positive and negative directions of the C-axis. With G03 can be solved. Video production is really not an easy job. If this video was helpful, why don't you give us a follow and a like? In the meantime, if there is anything that you would like to know about it, please share your thoughts in the comments. Your support is our continuous motivation. Thanks, guys.